whoever's watching this video.
Hello, whoever's watching this video.
All right.
No way. You should have been here. Don't get COVID.
Kyle thinks Mickey Mouse is hot.
2-7. All right, 2-7. There's only a front side to this note sheet, so we'll go through this rather quickly. Solving equations by graphing. We're trying to find solutions. And what we're trying to find when we are graphing these things is we're trying to find where it crosses the x-axis. So let's say we're doing like a parabola. We're trying to find these places right here. Maybe it's a linear function that does this. We're trying to find these places right here where he crosses, okay? So the height of a punted football can be modeled by this function right here. All right, how many pieces does that function have on the right side?
3.
1, 2. On the right side, it only has 3. 4 altogether if you can include the y. Okay. Now, what is the highest power of x?
Whatever one.
2.
X squared. This guy's parent function, if I strip away all of the numbers and everything else, is y equals x squared because it's the highest power. Now, what does y equals x squared look like if you graph it?
A parabola.
A parabola. Now, this minus sign tells me something else about my parabola.
It's going to be negative.
It's going to be negative. It's going down like this, okay? So what's happening is this is modeling the punted football. The football is being punted down here, and it's going up, and then it's coming back down. That's what a football does. It goes up and comes back down.
Can I ask a question?
Sure.
When you put the parent function, there's the negative, so why don't you put the negative in front of it?
Because the negative is a translation. The negative is a reflection down. So when we get rid of everything else, it's just x squared, and then the negative is like a transformation that's done to that x squared. That's a good question.
Oh, okay.
Yep. So, yeah, the negative and the 16 and the 10 and the 2, those are all added in there later, okay? So what's happening to this football is basically it's being a parabola. It's going up, and then it's coming back down. We're going to talk about him more in example 3, okay? Find the x and the y intercepts. All right, I'm going to give you some background information on x and y intercepts. X-intercept is where he crosses the x-axis, right?
Yeah.
Crosses x-axis. The y-intercept is where he crosses y-axis,
No.
right? This is stuff that you all should know. Let's talk about x-intercepts, though, okay? I'm going to talk about this point. Don't write this down. Talk about this point. This is the point 3, 0. That is an x-intercept. This is the point 7, 0. That's another x-intercept. This dot right here is the point -4, 0. That's an x-intercept. What do all of those 3 points have in common that are x-intercepts?
They're all the beautiful ones.
The y-coordinate is 0. So, put a little note over here that says for x-intercepts, the y is equal to 0, right? For the x-intercepts, all of these x-intercepts, the y-coordinate is 0. Okay? Now, I'm going to erase that, and I'm going to do some y-intercepts. So this guy right here is a y-intercept. He is the point 0, 1. This guy right here is the point 0, 5. This guy down here is the point 0, -4. This guy is the point 0, -7. Those guys are all y-intercepts. They're intersecting the y-axis. What do all of those points have in common? The x's are 0. So, star, 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 for the y-intercepts, the x is equal to 0. Okay, now, if I have an equation like this guy here, and I want to know where the x-intercepts are, and I want to know where the y-intercepts are, all I do is plug 0 in for y if I want to know the x-intercepts, and I plug 0 in for x if I want to know the y-intercepts. That's how that works. Does that make sense? Yeah? So let's do the y-intercepts first. I'm going to start over here on this section, okay? Starting over there. So y-intercepts, let's plug 0 in for x into this equation, okay? So y is going to stay just y, but now I'm doing 1/2 times, what? 0 squared, plus 1/2 times 0 minus 6, and I want to solve that thing after I've plugged 0 in for the y's, okay? 1/2 times 0 squared. If I simplify this part, what does that make? 0 squared. 0 squared is 0. What's 1/2 times 0? 0. Anything times 0 is 0, so that goes away. 1/2 times 0 here. This goes away, and it is 0. So y is equal to -6. It will always be the case, always, that when you're plugging 0 in for x, the number that does not have an x attached to it will be the y-intercept. Does that make sense? It will always be the case because everything else will cancel out because it will be 0. Okay? So the y-intercept is -6. I'm going to go down where he intersects the y-axis and put my dot at -6 right there. Okay? And now we're going to go back into the x-intercepts because these are just a little bit harder. Okay? Are we good so far? Am I going too fast? No? Now, to find the x-intercepts, I do what again? Plug 0 in for y. So I'm going to do 0 equals. I'm rewriting this equation up here, but y is going to be 0. It's 1/2 x squared plus 1/2 x minus 6. Okay, that is so disgusting. We hate fractions. We hate fractions. How can I get rid of the 1/2s? Okay, I'm going to multiply the entire equation by 2, and because I do it to the entire equation, it makes it legal. So I distribute the 2 through to all 4 pieces. Whoop. Okay? 2 times 0 is? 0. What's 2 times 1/2 x squared? Just 1x squared or just x squared? What's 2 times 1/2 x? Just 1x. And 2 times -6? -12. Okay, now, this is going to take you back a little ways. This thing right here, x squared plus x minus 12, he is a simple trinomial, right? Do you remember doing that? Yeah. Factoring stuff down, we had difference of squares, we had complex trinomials, simple trinomials. This one is a simple one, so we just simply look for the number that I can multiply together to give me -12, but when I add them, give me +1, because there's a 1 in front of the x, right? So multiply to get -12, add to get 1. What are those numbers?
3 and 4.
3 and 4, what combination of 3 and 4?
-3, +4.
-3, +4. Now, -3 times +4 is -12. -3 plus 4 is +1. Correct. Now that I have it broken down, I'm going to set both of those pieces equal to 0. So I say x minus 3 equals 0 and x plus 4 equals 0. Okay? Then I solve for x. So if I'm trying to get x by itself, I would add the 3 over. So x is going to be equal to 3. Okay? What will x be equal for this guy? I'm going to subtract the 4 over. So x equals -4. Okay, so what did I just find?
X-intercept.
The x-intercept. So 3 and -4 are going to be where he crosses the x-axis. So I'm going to plot those over here at +3 and at -4. And he's going to go down like this. Something of that nature. Okay, and that's what my parabola is going to look like. Okay, let's go back up and see what it was asking me to do. Find the x and y intercepts. The x-intercepts were 3 and -4. The y-intercept was -6, and graph the function. Done. Okay? Whenever you're finding the x-intercepts, you plug 0 in for y. Y-intercepts, you plug 0 in for x. Good? Yeah? Okay, now, the next thing that it will say is when we're trying to find the solutions, when we're trying to solve the graph, the solutions. Solutions are the same thing as the x-intercepts. They will also call them roots, or they will call them zeros. All 4 of those names mean exactly the same thing. Roots, solutions, x-intercepts, zeros, all of them mean where it crosses the x-axis. So if it says solve this equation, you're trying to find those places where he crosses. Ugh. Right here, these guys, where he crosses. Okay? All right, so let's go down. Find the root of the linear equation using algebra and by graphing the related function. Okay? So when we're doing that, we're trying to find the x-intercepts. It doesn't specifically ask for the y-intercepts, but we're going to do the y-intercepts also because that's going to help me to graph him. Okay? So x-intercepts, y-intercepts. X-intercepts, we plug 0 in for y. And y-intercepts, we plug 0 in for x. Okay, but I don't have a y. If I'm doing this first part, I don't have a y in this equation. What the heck? What? F of x is the same thing as y, right? We're big kids now, they call it f of x instead. So I'm just going to plug 0 in for y. And I'm going to solve for x. Okay, this is a linear function, by the way. How do you know that's linear?
Because it doesn't have anything weird in it.
It doesn't have anything weird in it. It just has an x and a y to the first power. No weird things. Okay, if I want to solve this thing for x, what are you going to do first? What would you move? 10. Subtract the 10. Move the 10 to the other side. So negative 10 equals negative 2x. Okay? Then, to get the x by itself, divide by negative 2. What's negative 10 divided by negative 2? 5. X equals 5. So that is my x-intercept. X equals 5. I'm going to go over to the 5 and put a dot right there on my graph. The x-intercept is 5. Okay? The y-intercept, we're going to plug 0 in for x. So y equals negative 2 times 0 plus 10. And I warned you the last time, I said, your y-intercept will always be the number that does not have any x's on him, right? Because negative 2 times 0 will just cross out, so the number that doesn't have an x attached to him is 10. My y-intercept is going to be 10. Okay, I'm going to go up to 10. 2, 4, 6, 8, 10. You can't really see it. It's just that top number right there. That's a 10. And he's going to be a straight line like that. Okay, now, we could have graphed this guy without using the intercepts, right? Negative 2x plus 10 just means I start at 10, I go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, right? That's what he looks like as well. But we could graph it using the intercepts like we did here. So we've got two different ways of graphing linear functions now. Okay, the way that we usually do it, and then the x and y intercepts. Good? Yeah? Okay, last thing, finding the zeros. Graph the function from the punting example. All right, punting example was up here. Negative 16x squared plus 10x plus 2. I'm going to write that down here. F of x equals negative 16x squared plus 10x plus 2. Is that right?
Yeah.
They get my positives and negatives. Okay. All right. To do this, we haven't studied quadratic functions very much. That's what we're doing in chapter 3 a lot. In fact, chapter 3 is entirely about quadratic functions. So if I want to graph this, I'm going to wait to graph it by hand until we get to chapter 3. But I'm going to use a handy-dandy Desmos website, and it's going to graph it for me. And we're going to see what this thing looks like. Okay? So help me remember that here in just a second when I get this wrong. I'm going to graph y equals negative. Where's my negative button? Can I just do negative? Yep, negative 16x squared plus 10x plus 2. Did I get that right? Okay, and this is what it looks like. And I'm going to zoom him out, make him a little bit wider, right? Okay, here my x-axis is the one here at the bottom, and my y-axis is here. Okay, so it starts at 2, it goes up and it comes back down, right? So if I graph it on yours, shoot, it logged me out. Why did it log me out? I don't know. What are we on? 2, 3? No, 2. What are we on? 2, 7. 2, 7. Okay, so it starts here at 2. It goes up and then it comes back down and does one of those. Okay, really it goes on this side as well. Okay, that's what my parabola will look like. Now, what is across here at 2? Let's label our x-axis and y-axis. Do you know what the x-axis represents? This guy right here. What's the x-axis talking about?
How far away?
Kind of, maybe.
It's not a kind of.
It is time. I'm pretty sure it's time.
No, it'd be
Yeah,
distance.
can be modeled by the function. The graph of the function can tell you how high the ball is during its rise and fall and when it hits the ground.
Oh.
When it hits the ground. When is talking about time. Okay, and what's the y-axis talking about? The height. Okay, so we have height versus time. Now, why does it start here at 2 instead of starting on the ground?
Because you don't punt it off the ground.
You don't punt a ball off the ground, right? You punt it 2. Is this 2 meters in the air? 2 feet in the air?
It better not be
2 meters would be quite a ways.
It's like
2 feet in the air. But you punt a ball higher than 2 feet in the air, don't you?
Not really.
I don't know. So we'll say height in feet. Okay. So this point right here. This point right here is physically the ball actually hitting my foot, and then it's going up into the air, and then it's coming back down. Okay?
You can't have negative time. So
You can't have negative time. That's why we're going to ignore this part, and we're going to ignore this part, because you can't have negative time, and you can't have negative height. Right? So those guys are gone. So we're just looking at just this part of the graph. Okay? I'm getting too many colors. Just this part of the graph. That's the only part that we care about. Okay? So it wants to know, what's the end question that we have to answer? Graph the function from the punting example above and use the graph to estimate the zeros. What do these zeros represent? Okay, what's a zero again?
Wherever it hits the line.
Where it hits the x-axis. So I'm looking at where he hits the x-axis. He touches it 2 places. We're going to talk about those 2 places. So this one here and this one here. Let's go back to my graph and we'll find where they're at. Here it is touching at. The thing that I really love about Desmos is I click on this line and it automatically gives me where the dot is located. It's awesome. Negative 0.16, we'll say. Remember that? Write that down so I can write it down here in a second. Negative 0.16. Okay? On the other side, if I keep going over, woo. Okay, he's going up, he's coming back down, and he's crossing right there at the point, 0.78, comma 0. 0.78, comma 0. Okay, 0.78, comma 0. All right, did I graph that right? Negative 16x squared plus 10x plus 2. Okay, all right, so this point right here was at the point negative, what, 0.16? What was it, 0.16?
Yes.
Negative 0.16, okay, is that guy. And right here, this point was at 0.78. Okay, what does that mean?
That the ball started somewhere in negative time. And that
Somewhere in negative time,
yeah.
and it touches there at 0.78.
So it's approximately a second away.
So approximately a second later, it's going to hit the ground,
Yeah,
which is probably about right.
No,
A
it's
second,
not.
a second is pretty is a long is a kind of a long time.
It is.
A second is a long time.
You're supposed to get to sit up there.
0.78. This person probably didn't kick it very far.
What do you mean?
It was an what is it called, offsides, whatever, an onside kick. It was an onside kick where you just like kick it and it like
If it's
goes.
an onside kick, it's sitting on the ground.
I don't know. This was a punt recovery kick. I don't know. Can you do that?
No.
Okay, I don't know. But anyway, this person is not very good. It's Donald Duck. Come on, he's not gonna kick very far. His legs
It's
are
a
short.
cartoon. He's
Okay.
supposed to be good at it.
So 0.78 seconds later, it's on the ground because he didn't kick it very far. It was really bad. It was a really bad kick. Okay, good. Good. There you go. We are trying to find the x and y intercepts. How do you find x intercepts again? X intercepts. Plug.
Plug it in,
Plug zero.
plug it in.
0 in for
Y.
y. Y intercepts.
Plug 0 in.
Plug 0 in for x.
Mm.
That's the whole meat and potatoes of the whole thing. Okay? You guys have a homework assignment, and it is like a handout sheet. And before I hand it out to you, I'm going to put this on video. So anybody who's watching this, skills practice, do all of them. Practice, do the evens. I won't make you do the story problem. So practice, do the evens. Skills practice, do all. All right? Say, everybody say goodbye on the video.
Hasta la vista, suckers.